Hello, my name is Austin Lambert, and this video is the presentation of my senior project at Dixie State University. First, let's take a look at the various goals that make up my project as a whole. The core goals of my project are the following. Implement 2 of the HOPE imaging goals, which is referring to the first of the HOPE goals we will look at in a second. Compare imaging cloning speeds of X-Ways or FTK, DD, the 2 implemented technologies from the previous goal, and a VOOM hardcopy 3P, as well as Dixie's Pixie server. Build a logon system using Samba to host students' user accounts and files. Problems with questionable software and large database software may need to be addressed. The HOPE goals for my project are the following. Implement 3 of the following imaging systems/servers: Clonezilla, Fog, Pixie, and DD over the network. Research other hard drive bay options and their costs. The dream goals for my project are the following. Implement all 4 of the HOPE imaging goals. Research and add extra technologies to the above list to possibly be implemented later. Research any other various technologies and possible solutions to the presented problem for the client. Now, let's take a look at a few items from my project that I would like to demonstrate. First, let's take a look at the imaging speeds of a few of the test case scenarios. First, we will test FTK, also known as Forensic Toolkit. The first test I ran using FTK was while using a USB dock for hard drives. It never occurred to me that this method would result in a very slow image. I stopped the process soon after I took this photo because it was taking too long to be relevant for the test. I then decided to put the hard drive directly into the motherboard via SATA, and the results were much better. The next speed test I ran was for X-Ways forensic software. The process for this test is identical to FTK's, and the results were also equally close. The next test I ran was with the VOOM hardcopy 3P. The video playing is a time-lapse that was then sped up of the VOOM during the image process with the final time at the end. I was also going to test the Pixie server built by DSU for use on campus, but at the time I was going to test the system it was down or the image was corrupted because it would get stuck in a blue screen rebooting loop after it finished imaging. I never re-attempted this test. The first demonstration is of using DD over the network to image and restore a drive. Though not the fastest option, this one can be pretty nifty to use over a network for remote imaging. These commands are essentially what can be run on each machine respectively to make this work. To restore a hard drive to a client, you would just reverse the commands and change some of the variables. It can be made multicast by using different ports other than 19,000 on other imaging sessions. On the screen now is a sped up demonstration and time-lapse of the full process. The last demonstration was my favorite part from my senior project. The video playing now is a screen capture of my implementation and deployment of a Fog server with a client, though I cannot use the time for this test in regards to the other tests. Due to some time constraints, I implemented this in a virtual machine environment within VirtualBox instead of on a physical machine with a full 500 gigabyte hard drive, though the process was still completed and worked very well. The video has been sped up, and there will be small text quotes that will be given in regards to what is being presented at the time in the video. In conclusion, I would like to look back at the goals and see which ones I completed and which ones still need more work or further research. As each goal is presented, the goals shown in green were completed during my project. Goals in yellow were attempted and may require extra research and work. Goals in red were not addressed within the time constraints. Regarding the core goals of my project, I was able to implement 2 of the Hope imaging goals. I also did compare imaging and cloning speeds of X-Ways, FTK, and the VUM hard copy 3P. I attempted this of the DSU Pixie server, but the image was corrupted at the time, and I was only able to fully implement one of the technologies from the previous goal. I also did not look at doing just a normal DD image, as it is very similar to X-Ways and FTK. I was able to build a logon system using Samba that would have been able to host student accounts and such, but there was trust issues between the server and the client. I believe these to be due to blocked ports on the network. As far as the Hope goals go, I did implement Clonezilla, Fog, and DD over the network, though Clonezilla had a lot of corruption issues when taking the image and often wouldn't cooperate. Fog worked perfectly well, and DD over the network also worked really well, though it was one of the slower options. I did not have time to look into implementing my own Pixie server. As far as researching other hard drive bay options and their costs, I did do some research, but later, after working with the client, realized that the current hard drive bays that we are using in the lab is probably the best option. In regards to the dream goals for my project, I was not able to implement all 4 of the Hope imaging goals, as I was not able to get to implementing my own Pixie server. I did research other technologies that could possibly be added to the list to be implemented later, but not to the level to be added for the project. I also didn't spend much or any time researching other various technologies or possible solutions for the lab, as after talking to the client, we quickly realized that the hard drive bay option and current procedures are the best solution for the lab. We may possibly implement a Fog server for the lab in the future. Overall, I felt this project was a great learning experience on numerous levels. I hope you enjoyed this presentation, and this concludes my senior project.